go and take your textbooks out. Open to page number 20. You get pages 20 and 21, the homework section, numbers 1 through 20. Excellent. Good. See. Oh, there they are. Good. Okay, excellent. Oh, all right. Good. All right. Excellent. Some of it done on paper 7 book. All right, let's go and take a look at this together. We were working on our prime factoring most recently. Let's very quickly review what are our prime numbers. Let's see if we can remember after a weekend. See how our memory is, class? 2, 3, 5, 7, 11, 13, 17, 19. That was pretty good. Let's try it again. 2, 3, 5, 7, 11, 13, 17, 19. We were using those prime numbers, and we also talked about prime numbers existing, prime factors existing more than once. For instance, if you took the number 8 and prime factored it, you get 2 times 2 times 2. Well, that's 3 2s. Rather than write 2 times 2 times 2, lazy mathematicians came up with a faster way. How would we say it, Bryson? Sam, help him. Exponent. With an exponent, and so we would write the 2. By the way, class, the 2 would be called the base, and the 3 would be our exponent. To remember how we read an exponent of 3, Jalen?
2 cubed.
2 cubed is how we read it. What if we had, for instance, 5 times 5, right? That would be a base of 5, an exponent of 2. How would we read that? Kirsten?
5 squared.
5 squared. What if we had, like, for instance, 81? I think we prime factored that the other day, and it came out to 3 times 3 times 3 times 3. So how would I read it if the base is 3 and the exponent is 4? Corey?
3 to the 4th power.
3 to the 4th power. Or some mathematicians are so lazy they leave off the word power. Because, like, the 4th, what else? Like, there's no other 4th anything you'd raise it to. So just 3 to the 4th would work as well. What you were supposed to do on numbers 1, 2, and 3 was simply rewrite the group of factors using exponents. Number 1, how did you write that? Michael?
I wrote it.
Number 1 from the homework. It was told you to rewrite 7 times 7 times 7 times 7 with an exponent.
7 to the power of 4.
7 to the power of 4. Okay, 7 to the 4th is what I was going for, but that works. Now, number 2, we had to be careful here because it wasn't all, bless you, the same factor. What did you get for 2, Kirsten?
11 squared times 13 squared.
Excellent job. 11 squared times 13 squared. By the way, notice they use the little X multiplication symbol. What's another symbol we could use, Elaine?
A raised dot.
A raised dot. Anyone happen to use a raised dot by any chance? Good, several of you did. It's lazier and easier, isn't it? So I'm a fan of that, but nothing wrong with the little X for now. How about number 3, Ben?
3 times 5 third.
To the 3rd is correct. Do you remember the special way we can say it? Class, help him? Oh, we got it. Cubed. There we go. 3 times 5 cubed. But again, it's not wrong to say 3 times 5 to the 3rd power. Good job. Number 4, you actually were supposed to prime factor the 150. And it said to use division of primes. Honestly, if you want to use the factoring tree, I'd be okay with that. Elaine, what's a good way to split up a 150?
I don't know. I did it the other way.
You did the division of primes? Well, I mean, any number that ends in 0 is divisible by 10. So we could at least do
10 times.
Don't make this hard now.
15.
15, there we go. 10 times 15. And then the 10 could be factored again into
2 times 5.
and the 15 could be factored into
3 times 5.
And since these are all prime numbers, you can't do any more factoring. How would we write the answer? And again, I know you didn't do it this way, but same answer either way. Number 4?
2 times 3 times 5 to the 2nd.
Or in other words, 2 times 3 times 5 squared would work. Good. How about number 5? What did you get for your answer? Regardless of whether you use the tree or division of primes, when you prime factored the 90, Griffin.
2 times 3 times 3 times 5.
Okay, but then using exponents instead of 2 times 3 times 3 times 5, 2 times
3 squared times 5.
There we go. 2 times 3 squared times 5 is correct. And number 6, what did you get for your answer?
11 cubed.
Not 11
Squared.
cubed squared. There we go. 2? Yeah, squared. 3 times 11 squared is correct for number 6. Number 7, you were supposed to expand it out and multiply 5 to the 4th, but you were supposed to actually do 5 times 5 times 5 times 5, Jalen. Really big number.
625.
625 is correct. Number 8, 2 to the 6th power. That's a lot of 2's, Corey.
64.
64. Number 9, 13 squared, Luciana.
169.
Excellent. Number 10, 7 cubed. What did you get, Bryson? 343 is correct. Number 11, 3 times 4 squared. Now notice those aren't prime numbers there because 4 isn't prime. But, oh well, we still use it. What did you get for your answer, Sam?
36.
For number 11, so we got a 3 times 4 times 4. What is 3 times 4? 12. And then 12 times 4? 48. There we go. Should have been our answer for that one. But for redemption, Sam, let me come back to you on number 12. 2 cubed times 12. Wasn't quite sure what to do. Okay, so let's take a look at this real quick. So 2 times 2 times 2 times 12. 2 times 2 times 2 times 12. Ooh, maybe a little shaky on our 12s. Class? 96. 96 would have been our answer there. Any questions on 1 through 12 before we move to the next page? That's all for page 20. Any questions on those? All right, look at the next page. Number 13 is true or false. True or false, the number 3,171 is divisible by 9. Corey?
3.
False. It's only divisible, well, it's divisible by, as far as rules we memorized, and they're not up there anymore, it is divisible by 3, but not by 9. Good. Number 14, true or false, the number 18 is a composite number, Luciana.
True.
That is true. Number 15, that number, 3,846, rounded to the nearest 10 is 3,850. Griffin?
True.
True. That is correct. The 6 bumps the 4 up to a 5, and of course the 6 then becomes a 0. Number 16, writing prime factorization. This time they said don't use exponents. Write it out the long, slow, painful way. And let's go to Sam for number 16. Good. 2 times 2 times 2 times 5. How many, as you were writing that, thought, gee, I wish I could use exponents? All right. Let's see, number 17. 270. Really big number. Paige, what did you get?
2 times 3 times 3 times 3 times 5.
Good. 2 times 3 times 3 times 3 times 5 is correct. And number 18, 300. When you prime factored that, what did you get, Elaine?
2 times 2 times 3 times 5 times 5.
Good. 2 times 2 times 3 times 5 times 5. Number 19, what's the only whole number that isn't also a counting number, Kirsten?
0.
0. Number 20, they've got 2 different groups of numbers. Letter A, what do all 4 of, I can't count, what do all 3 of those numbers have in common? Jalen?
They're negative.
They're all negatives. You can't say they're all integers because the last 2 aren't. But they are all negatives. How about letter B? What do all 4, 5, I can't count. What do all 5 of those numbers have in common there? Michael?
0 positive.
Until the last one, they were all integers, and they were all counting numbers, and they were all whole numbers, but then 5.6 messed it up, and it had to only be that they were all positive numbers. Any questions on 13 through 20? All right, any questions at all on the homework? Any questions at all? All right, look back across the page, back at page 20 again, and I'm going to let you pick. You can use either the division of primes, which they got the little half box ready for you, or if you want to go with the factoring tree, that's fine. I want you to do numbers 11 through 13 on page 20, prime factor, and write the prime factorization with exponents. Use exponents. Be lazy. 11 through 13 at the top of page 20. Remember, factoring trees, split it up however you want. Just make sure you keep splitting until you get only prime numbers. If you use division of primes, try to start with your smallest prime number and go from there. Some people already done with all 3 of these. Wow. just a little longer. I'm doing really well with this. All right, number 11. Sam, what'd you get? 2 to the second power? What was your little exponent? All right, so did you do division of primes or the factoring tree? Division of primes, okay. And you started by dividing by a 2, I assume? And you got what? 16. Then you divided by another 2? You divided by an 8 and got 2. And here's the only problem. You can't divide by an 8. Only use prime numbers, 2, 3, 5, 7, 11, 13, 17, 19. However, if you wanted to go with the factoring tree, you're allowed to use other numbers. You just have to keep going. So for instance, if you'd said this splits into 2 and 16, this splits into 8 and 2, you'd be fine because you could still split the 8 again into 4 times 2, and then the 4 could split again into 2 times 2. So my prime factors are all of these. So what would my answer be? 2 times 2. Right. How many of them are there? Count. How many are there? Count how many 2's are in that loop. 5 of them. So we would say 2 to the 5th power. There we go. Now again, if you're going to do division of primes, you've got to stick with the smallest prime possible. You will get 2 times 8, but the 8 has to be split again into 2 times 4, which has to be split into 2 times 2, and there's your 5 2's that way. A little neater to see them all when you use the division of primes. How about number 12? What did you get for your prime factorization then?
3 times 3.
3 times 3, but with the exponent like it instructed?
3 squared.
Squared, there we go. 3 squared is correct. How about number 13? Griffin.
Without change, 2 squared times 3.
2 squared times 3 is correct. How many got all 3 of those right? Good, excellent. Any questions on those? I want you now to do numbers 17 to 22. 17 to 22. As we finish up that lesson from Friday. I'm going to expand these out and multiply. Let's see what we get. Several people already done with these. Question?
Do we need a P though?
That's the plan.
Okay.
About 30 seconds longer. Looks like most of us are about finished. So write them all out first, and then just multiply as you go. All right, let's take a look at these together. Number 17, 2 cubed. What did you get, Jalen? 8 is correct. Number 18, what did you get? Luciana? 128. Number 19, what did you get, Paige?
50.
50. Number 20, Kirsten? Careful, 2 cubed isn't 6. 2 times 2
2 times 2 is 4.
times 2,
Is
8 times 11 would have been 80. I see that one a lot though, so you're like the umpteen millionth person in my years of teaching to do 2 cubed is 6. So, and again, it's so tempting, right? But 2 times 2 times 2 is 8, so 88. How about number 21? What did you get for that answer, Ben?
250.
Well, not 250.
250.
250 is a correct. Good. Number 22. What did you get for this answer? Sam, did you get that far?
Yeah.
What'd you get?
22. 24. Or 22.
Yeah, for number 22. Oh, okay. 63 is almost there. You thought 3 times 3 times 3 times 7. If you just do this part, yes, because 3 times 3 is 9 times 7. But again, 3 cubed means there's 3 3s. So no, let's see. Page?
189.
189. So I think you fell into the same trap Kirsten did. She saw 2 cubed and she's like, I don't need to write that out. 2 cubed is 6. I got this. And I think you went to the same trap. You're like, 3 cubed, I don't need to write that out. 3 cubed is 9. I got this. Careful. 3 times 3 times 3 is 27. So it would help to, it says expand and multiply. It would help to expand it out first, then do the multiplying, so you don't make that little mistake. All right, speaking of powers, if you look at the next lesson, talking about powers of 10, we got this, I think. What is 10 squared, 10 times 10, class? 100. We know that 10 times 10, or 10 squared, is 100. Now, 10 cubed would be, of course, 10 times 10 times 10. 3 of them, right? Where 10 times 10, class, is? And if you were fortunate enough to have 10 $100 bills, how much money would you have, class? $1,000. We'd be doing really good right about now. But what if you took that same 10 times 10 times 10, or 1,000, and multiplied another 10? Class, now we'd be up to $10,000. Well, notice something. When it's a 10 squared, notice there's 2 zeros. 10 cubed, 3 zeros. 10 to the 4th has 4 zeros. So, how many zeros do you reckon 10 to the 5th gonna have? 5 zeros. What you reckon that gonna be? 100,000. Does it make sense what the different powers of 10 would be? Basically, whatever the power is, that's how many zeros there are. But now imagine this. What if I multiplied 6 times 100? That is to say, if I had 6 $100 bills. Class? $600. Basically, just stick the 2 zeros on the back of the 6. What if I multiplied 8? And they don't make $10,000 bills. I think the largest bill in the US currency right now is a $1,000 bill. But let's suppose, just hypothetically speaking, this is Monopoly money or something, and there's 10,000. Just kidding, I don't think Monopoly goes up that high either. Let's say there's $10,000 bills, and we have 8 of them. How much money is that, class? 80,000. Right? We just take those same 4 zeros and stick them on the back of the 8. So when you multiply by a power of 10, if you're multiplying a whole number, just stick the zeros on the back. What if I had, let's go small numbers here, 5 $100 bills, class? That'd be 500. Now, we have to break from the $100 bills here, okay? Because you can't have a partial $100 bill, right? Torn bill, okay? That's again, I think it's against the law to tear up money. Anyway, but let's suppose we have 5.3 times 100. Okay, so forget the money for a minute. Do you realize that since 5.3 is between 5 and 6, my answer is going to be between 500 and 600? Does that make sense? And if I were to multiply this, remember what I said to do is multiply the 1 and hang the zeros, right? Well, what's 1 times 5.3, class? 5.3, but you have those 2 zeros we hung, remember? And we have to put those in before we put in the decimal. And notice what we get, class? 530. Well, that makes sense, right? That's in between 500 and 600. Notice essentially what we did. We took the decimal, and it's as if we moved it back 1, 2 times and filled in the gap. Technically, where is the decimal in the number 5, class? At the end. And technically, if we move it back twice, add in 2 zeros. Look in your book on page 21 there at the bottom. Notice the example that they have. They have a 0.63 being multiplied by a 10. Well, since there's 1 0, class, they moved the decimal back 1 place and got 6.3. Again, if they wanted to, they could have multiplied it by 10 like normal. Hang the 0, that's a 3 and a 6, and there's 2 decimal places. But it's faster to just move the decimal. Write that in the side margin of your book. To multiply by a power of 10, to multiply by a power of 10, to multiply by a power of 10, move the decimal to the right. To multiply by a power of 10, we're at the bottom of page 21. To multiply by a power of 10, move the decimal to the right as many places as there are zeros. Move the decimal to the right as many places as there are zeros. So what if I'd taken a 0.63 and I wanted to multiply it by 10,000? Class, how many zeros are there? 4. So how many places do I need to move the decimal?
4.
Watch. 1, 2, 3, 4. What do the 2 last gaps get filled in with, class? Zeros. So what's my answer?
6,300.
6,300. Rather than taking the time to hang the zeros, multiply the 1, put the decimal back. Again, nobody got time for that, right? We're lazy. We want to find shortcuts. This is a great shortcut. Now, does it work the other way? Sure. But this is even faster, right? Look at the next example. In letter B, notice they did not write out the number. They wrote 10 cubed. Do you see that? But remember what the exponent means, class? All the exponent does is tell you how many zeros there are, remember? So if it's a 10 cubed, how many zeros, class? 3. So how many places do we move the decimal? 3. And so they moved it to the right 3 places. Boink, boink, boink. And they got 518.4. Make sense? Questions on that? All right, turn to page. Turn to page. We've already looked at this, but I want to look at it again. There's a little small blue shaded box at the top. Inside the blue shaded box, following along with me in your textbook, they have a 2.3 times 10 cubed. Again, if it's written with an exponent, the exponent tells you how many zeros. How many zeros, class? 3. So how many places do I move the decimal? 3. But notice there's only 1 place there. So the next 2 places both have to get filled in with zeros. So do you see how they got 2,300? Look at the next example box. They have a 0.9 times 10 squared. How many zeros, class? 2. So how many places do I move the decimal? 2. And so when we move to the right 2 places, boink, boink, the first boink goes to behind the 9. The next boink adds a 0. They got 90. Make sense? Look at the last example, then we're going to do some of these together. Letter B. They've got a 0.76 being multiplied, class, by what? 10,000. How many zeros? 4. How many places does decimal move? 4. The first 2 are the 7 and the 6, but then they had 2 more, so they filled them in with zeros. Does everyone see where they got 7,600 from? Any questions on that? All right. Remember, if you don't see a decimal, where is it? Behind the number, at the end of the number. I want you to do the first box on page 23. So page 23, numbers 1 through 4. Page 23, numbers 1 through 4. I want to get this shortcut nailed down so we can be uber fast. 2. All right, several people finishing up. Take about 45 seconds. No noise is needed. Except because we're lazy, we don't want to write all those extra zeros. So all we're doing is moving the decimal. Now here, when I move the decimal, it forces there to be a 0. But here, when I move the decimal, I'm forced to put a 0, so I wouldn't bother because I'm lazy, right? So move it. You don't need any zeros. Move it twice. Don't need any zeros. Only for the zeros if you need them. All right, pencils down, even if you're not finished. The first number they give us is 63. They want us to multiply by 10, class. How many zeros? 1. How many places do I move the decimal?
1.
Where is the decimal?
At the end.
So if I move it one place, what do I have to put in the gap?
0.
A 0. For the next number, we multiply by 100. That's 2 zeros. I move it again. Now it's another 0. 6,300. For the next one, I move it another time. That gives me another 0, which gives me 63,000. There's your 3 answers. So basically, if it's a whole number, class, if there's no decimal, you really are just tacking zeros on the end. So for 946, you multiply by 10. What do we get, Luciana?
9,460.
Good, 9,460. If we multiply by 100, Bryson?
960, 4600.00.
Well, we don't need 0.00 because we're lazy, right? But so it's again, Bryson, it's a 946. We're multiplying by 100. That means we move the decimal twice, which means we fill in the 2 spots with 94,600. We done. That's all. Does that make sense? Yes or no? Okay. We multiply by 10 cubed, it says. Well, if there's a 10 cubed, class, how many zeros is that?
30.
So how many places do we move the decimal, class?
30.
I've already moved it once, twice, now I'm going to move it a third time, fill it in with another 0 to get what, Sam?
500,460.
What does this say?
946,000.
There we go, 946,000 is correct. Do we get 1 and 2 correct? You're basically adding zeros onto the back of the number. But as soon as you come to number 3, they have a 0.847. By the way, does the 0 mean anything in front of the point? It's just their way of making sure you don't miss the fact that there's a decimal. So they put the 0 there so you can see it. Guess who's really lazy and never writes the 0 in front of the decimal? This guy. Yeah, so you don't need to write the 0 either. But when I multiply by 10, when I move the decimal, class, do I need to write any zeros? No. I'm just going to write 8.47. That's what we get when we multiply by 10. Just move the decimal one time. We done. For the next one, I've got to multiply by 100, class. That means move the decimal twice. So there's 1, 2. Now what am I going to get, Bryson?
84.7.
Do I need to write any zeros, class? No, bottom line is only write zeros if you have to because you are lazy. Right, the indoctrination is starting to take. Be lazy. Don't do extra work if you ain't got it. And then we multiply by 10 cubed, class. That's 3 zeros. So move the decimal again. And what do I get this time, Corey?
847.
Try that again.
847.
847 is correct. How many of those 3 answers for number 3? Number 4, what did you get when you multiplied by 10, Michael? 792.43. How about when you multiplied by 100, Kirsten?
For 7,924.3.
0.3, you caught it. 7,924.3. And then when you multiply by 10 cubed, Ben?
$79,243.
Oh, you were doing so good, and you slipped an hand in there. 79,243 is correct. All right, does it make sense now? Even if we didn't get them all, do we feel like we understand it better? Are there any questions still? You say, I'm still a little confused how you got that, or why you did that. Any questions? How many got them all right? You went 12 for 12. All right, I want you now to do numbers 5 through 15. Go ahead and do 5 through 15 now. And you just focus on moving the decimal to the right, depending on how many zeros or whatever the power is, because that tells you how many zeros. 5 through 15 now. Wait, where's the decimal? No, it's not. It's right there. So when you move it, right? So when you move it, it's not here anymore. And do I really want to write that 0? Because I'm lazy. There's your number. Makes sense? Good, Elaine. Good, Jalen. Corey. Sam finished. Good. Just another minute or so to be finishing up these 10 problems, 11 problems. Tired, Michael? Anyone in here, their power go out yesterday? Corey, I know your brothers were telling me yours did. Yeah, so they were telling me no air conditioning, no fans, no nothing on a really hot day. Yes, sir.
Do you know if the Boys and Girls Club, did the fence get torn down or did it
Blow down. I know there were a couple of fences in town I saw that were blown down by the storm last night. Some trees got blown down, some roofs got damaged. So yeah, it was pretty bad, especially right around the Manchester River Road area. It really got torn up. All right, anyone need more time? Anyone still working? Okay, Luciana, take about 10 seconds to get one more done. Yes, sir.
The lightning from it struck only 100 feet away from our house.
Holy cow. So I bet that was really bright and really loud. Yeah. And really instant too. Like whenever you hear flash bang instantly, it's like, oh. Sometimes did the house shake when it? Oh man. Well, praise the Lord, it wasn't your house. Yes, ma'am.
Were we supposed to do 5 through 15?
Yeah. All right, let's take a look at these together now. Number 5, what did you get for your answer, Griffin?
300,000, 326,000, no, 32,600.
32,600 is correct. Takes a minute, right? We're used to writing them. Saying them out loud is a little bit more of a challenge, isn't it? 32,600 is correct. How about number 6, Elaine?
821.
821. There were 3 decimal places, and you got to move all 3 of them out. How about number 7, Ben?
830,060.
Good. I'm not going to quibble over the and. 830,060 is correct. That was a tough one. Number 8, what did you get for your answer, Kirsten?
241,172.
Beautifully read. 241,172. How about number 9, Michael?
325,000.
That's correct. Yes. 325,000 is correct. Number 10, what did you get, Corey?
650.
650. Number 11, Jalen.
2,220.
Perfectly read. Number 12, Paige.
2.72.
Yeah, we only got to move it back one place, so 2.72. Excellent. How about number 13, Sam? 8 is correct. Hey, gotta love the easy ones, right? Number 14, what did you get, Bryson? No, what? 10 is correct. 10 is correct. And then number 15, what did you get, Luciana?
361.
361 is correct. How many got all 11 correct? You got them all. All right, any questions on any of them? Do we need to see any of them shown? How did you get that? All right, now here's the big deal. Watch it this way. When you multiply, you move to the right. Think of it this way. 5 times 10 gives 50, right? What would you get if you divided 5 by 10? Let's suppose, for sake of illustration class, that you had 5 candy bars, and there were 10 people who all wanted candy bar. How much would everybody have to settle for? You have 5 candy bars and there's 10 people. Class?
1/2.
Half a candy bar, right? Because 5 divided by 10 is 5/10, or 1/2, or 0.5. Notice that when you divide by 10, here's your decimal. Instead of going to the right, which would make it a bigger number, you would go to the left, which would make it a smaller number. So here's the key. Multiply right. Divide left. I want you to write that at the top of page 22. Multiply right, divide left. Now, I don't know, this is really corny, but I'm going to share it anyway because it helped a student one year. I had a student one year, he just couldn't remember which direction do I go. And so I thought of this, MRDL. Okay? And I told him, remember this. Everybody one day looks forward to the day you get your driver's license. Okay, now this is what you would say to like a 2-year-old, I know. But I told him, remember, Mr. Driver's License. It's stupid, I know, but it helped him remember. Multiply right, divide left. And if it helps you, great. If you think that's stupid, I admit it may be a little bit. But if it helps, right? So multiply right, divide left. Multiply right, Mr. Divide left, driver's license. Okay? So look at the examples on page 22. When we divide by powers of 10, we're still just moving the decimal. Look right above example 1.5c. They take a 4 and divide by 10. Well, that's the same as the 5 divided by 10. You just move the decimal to the left one time, class, and you get 0.4. But if you divide by 100, it moves again, and this time it has to be filled in with a 0. We get 0.04. If you divide by 1,000, that's 3 zeros, so you move it 3 times. That's 0.004. Does that make sense? Look at the examples now here in the shaded box. 418 divided by 10. How many zeros, class? 1. So move the decimal 1 place, but you're dividing, so go to the left. Boink! Over 1 place, you get 41.8. Does everyone see that? Look at the top of the next page. 0.16, and they're dividing by 10 cubed. How many zeros, class? 3. That's what the 3 means, is 3 zeros. So dividing, you go to the left. So you go to the left 3 places. Look where the decimal already is. All 3 places have to be filled in with zeros in this case. 0.00016. Does that make sense? Again, only fill in zeros if you have to. Don't put zeros if you don't have to. They had to. Does that make sense? Yes, sir. Might grab a couple tissues this time. All right. I want you to try that box, 16 through 19 now. You do the box, numbers 16 through 19. Let's see how we're doing with these and make sure we've got a good understanding. Again, it's all about moving the decimal as many places as there are zeros. But since we're dividing, we're going to the left. That is, we're making them smaller numbers. You worked ahead, didn't you? For shame. Did you work ahead too? Or are you just that fast?
I started while you were talking.
I mean, you weren't listening. You weren't hanging on every word with raptured attention. My feelings are hurt. I'm over it already. Next time, listen while I'm talking. Because there will be opportunities, by the way, this year for candy. But if you've worked ahead, obviously I couldn't call you the winner. So make sure you're not working ahead, because then you disqualify yourself from winning candy from time to time. So that would be a shame. All right, now careful. We're going to the left with the decimal, right? So we're not putting a 0 on the end, but if we move it this way, now we need that 0. If we move it a second place, that means we now need a second 0 before the 769. Does that make sense? Oh, you've been multiplying this we're going to the left because we're dividing. So go that way with the decimal. So go that way once, go that way twice. Right, correct. And the decimal goes this way. We get that for our answer. Right. Gentlemen in the back. Don't land yourself in detention. Peace, be still. All right, they start us off with the number 382. If you where is the decimal, first of all, class?
At the end.
At the end. If you divide by 10, that's how many zeros?
One.
1. We move the decimal which direction when we divide?
Left.
Left. So they go to the left one place. What does it make the number, class?
38.2.
38.2. What if you divide by 100?
3.82.
3.82 because you move the decimal another place. What if you divide by 1,000?
0.82.
0.382 because it's now moved 3 places. How many had 38.2, 3.82, and 0.382? Anyone say, I'm a little lost here. I thought I had it, but I didn't. Okay, let's work on the next one. Let's take the number 78. And if we divide it by 10, how many places do we move the decimal page?
1,
Just 1. Where is the decimal?
2.0.
No, where is the decimal?
At the end.
At the end. I move it how many places?
1,
Once. Which direction?
left,
To the left. If I move it to the left, it's going to go right here. What does that make the number now?
7.8.
7.8. That's all we got to do for dividing by 10. What if we divide by 10 squared or 100? Well, now instead of moving it one place, I have to move it.
2,
So I move it once left, twice again. Now what do I get for my number?
0.78.
0.78. What if I divide by 1,000? Now that's 3 zeros. So we need to move 1, 2, 3.
0.07.
0.078. There we go. And this time we had to add a 0 because we'd run out of room. All right, how many had those answers for number 17? Number 18. This is kind of annoying, but it's the way it goes. The decimal's at the front of the number already. So if I move it one place to the left, I'm already adding in a 0. Check your answer. 0.0769. 10 squared, that's 2 zeros. That's 2 places. Move it again. 0.00769. And then if I divide by 1,000, Jalen, we get?
0.0000769.
I think you have 1 too many in there.
Yeah.
I think, do you have 3 zeros or 4?
I had 3.
3. Okay, so you said 1 extra. 0.000769 is correct. So you had it written correctly, just got carried away. Number 19, what if you divide by 10? What do you get, Bryson?
14.301.
Well, 0.301, that's what they gave you, right? They started you with a 14.301. So if I divide it by a 10, okay,
No. 1.4.
1.4301 is correct. What if you divide by 10 squared, Sam? 0.14301. What if we divide by 1,000, Kirsten?
0.014301.
There we go, and there's our 3 answers for number 19. If we missed them before, does it make more sense now? If you follow what we're doing here. How many got all 12 correct, by the way? You got all 12 of them. Look at several of you. If we missed them, do we understand it now? Same thing we were doing before, but we're going left with the decimal. Do 20 through 31 now. Your numbers 20 to 31. I believe these are all division still. Yes. Now the fun one is when they mix it up.
Yeah.
By the way, do notice they've got a couple times they use fraction bars. Remember that a fraction bar it's no different. We don't need to react. It's just another way of saying divided by. So on number 22, when it says 979 over 10,000, it just means divided, or 100,000, it just means divided by 100,000. It's no different. They just chose to use a fraction bar instead of a division symbol. It means the exact same thing. Don't let it throw you off. you're dividing by 10, not multiplying. So you don't stick a 0 on. Here's the decimal at the end. Only put one place to get that. So put the decimal at the end and then move it. Put the decimal at the end and move it. Does that make sense? Now here you've already got a decimal, so you can just move what's already there. Okay? Freezing. All right, Michael, number 20. What did you get when you divided 14 by 10? 1.4. Number 21, Kirsten, you divided 360 by 10 squared.
3.6.
3.6. Number 22, you divided 979 by 100,000, Corey.
0.00979.
Good, 0.00979. We had to move 5 places to the left. Number 23, 6.25 divided by 100, Luciana.
0.0625.
0.0625. Number 24, 946 divided by 100. Bryson? 9.46. Number 25, 0.847 divided by 10 cubed. Jalen?
0.000847.
Good, 0.000847. Number 26, 83.6 divided by 10 to the 4th, or 10,000. Ben?
0.008836.
Good, 0.00836 is correct. Number 27, 241.172 divided by 1,000. Elaine?
0.241172.
Don't pack up yet. 0.241172 is correct. Number 28, Sam?
0.000325.
I think you should have actually had one more zero. Should have had 4 zeros? Because there's 5 places you move it. There's one, the first place is under the 3, and then there's 4 more. So 0.0000325. Number 29, 6.5 divided by 100. Paige?
0.6500.
Well, we don't need to add zeros to the end. We're dividing by 100, so we need to move the decimal how many places?
2.
2 places to the
Left.
left. So there's 1, 2. What do I need to have?
0.
So 0.065 should have been our answer for that one. Number 30, Griffin.
0.00222.
Excellent. Number 31 should have been 2.72. Questions on that? Anyone perfect? 12 for 12? Got them all correct? All right. Questions on any of those? Homework for this evening is to do page 24. Page 24, the homework, numbers 1 through 17. Page 24, the homework section, numbers 1 through 17. Take a look at that tomorrow. Review over that a little bit more tomorrow as well. Have a wonderful rest of your day, and you are dismissed.
What was it?